All right, section 8.4 is multiplying and dividing fractions. Multiplication is first. Before we multiply fractions, we want to be able to cancel out like terms, like the same thing divided by the same thing is 1. It makes things a lot easier. For example, if you have 3 over 5 times 8 over 6, you don't necessarily want to multiply straight across. You want to think about this here as 3 divided by 3 is 1 and 3 divided by 6 is 2. So you can make these numbers smaller, because if you think about it, 3 divided by 6 is the same thing as 1/2. So then the answer would be 8 over 10. Oh, in fact, I could have divided that into there. The 2 could have divided into here and made this 4. So the answer would have been 4/5. So that's what you're trying to do, is you're trying to reduce things down and make it smaller. So I'm going to factor first. 4 would be 2x minus 1. Taking out the common factor, 5, 2x minus 1. 2x minus 1. Hello.
Hi. She won't let me.
Alright, somebody walked in the door. Now I'm ready to go again. This isn't written very well, so I'm going to scratch this whole thing out. So it's 4 parentheses 2y minus 1 over 5 parentheses 2y minus 1. So that'll be nice. Those will cancel out hopefully. Then 5 times x minus 3, and then 3 times x minus 3. So restrictions first. So x cannot be, I guess it's y. Y cannot be 3, because 3 minus 3 would be 0. And y can also not be 1/2. So you pretend that this equals 0, you add 1, divide by 2. So those are the two restrictions, 1/2 and 3. Then we'd start canceling. Now it doesn't have to be diagonal from each other to cancel. It can be just it's just the same thing divided by the same thing. So the same thing divided by the same thing here is 1, and there it's 1. And then also it's diagonally 5 divided by 5 is 1. So everything goes away or becomes 1s. So technically they don't disappear, they become 1s, but 1 times anything is itself. So what we have left is 4/3. Alright, next problem. Taking out the common factor of 2, and we're left with x plus 6. Taking out the common factor of 3, and we're left with x minus 3. And then over here, take out the common factor of 2, it's x minus 3, and the common factor of nothing, 3x plus 8. So that one doesn't have a common factor. So the restrictions would be x cannot be 3, because 3 minus 3 would be 0. And then if you pretend that this equals 0, you would add 8, divide by 3, x cannot be negative 8/3. So these cancel. That's the only thing that cancels. So we're left with 2 times 2, which is 4, times x plus 6 over 3 times 3x plus 8. And then if you distribute the 3 and the 4 through, you get 4x plus 24 over 9x plus 24. And then that's the final answer there. Alright, so all it changes really is just the factoring. Down here, we're going to factor difference of 2 perfect squared, so it's x plus 2, x minus 2, over x plus 1, x minus 1, times x plus 1, doesn't factor. Then we can take out the common factor on this one. So we're combining our different kinds of factoring. So I take out the common factor on this one, and then this is the difference of 2 perfect squares. Okay, now we look for crap to cancel out. Bum, ba-dum, bum, gone, gone, bum, ba-dum, bum, bum, and that's it. So on the top we have x minus 2 over x times x minus 1. I forgot to do the restrictions. So 1 and negative 1, 0 and negative 2. So there's lots of restrictions on this. Let's put them in numerical order. So negative 1 on this one, 0 on this one because it couldn't be 0. The next one is 1, and then, oh crap, -2. Well, they're kind of in order, except for that needs to go over there. Anyway, I tried. 4, more factoring. So we get x minus 2, x minus 3 over x plus 2, x minus 3. This one has a lot of factoring. Lots of factoring. X and x, plus 1, plus 2, x minus 3, x plus 1. Now we get out the red pen and we start hacking away here. Boom, 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 boom. So you can hack away between fractions, or in one fraction or between fractions. Wait a second. X plus 2, x minus 2. That's a minus 2 there. I was going to say, weird. Hack, 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 hack. So everything hacked away, but the answer is not nothing. The same thing divided by the same thing is 1. So it's really, this went away, so that's 1 times 1 times 1 times 1. So 1 times 1 times 1 is 1. So the answer is 1. Okay, and then the restrictions would be x cannot be -2, 2, 3, and -1. There we go. So you just, what number goes in there to make those all 0. So the next page is division. So with division, I learned this from a 7th grade math teacher just recently. It's the old phrase, keep, switch, flip. So we keep this fraction the same. We multiply, and then we flip this one. So what are we doing? We're keeping this the same. We are switching this and we're flipping this. Okay, now things can cancel out. We think about this as x over x cubed, so this goes away, so this is x squared. We think about this and this going away, so this is y squared. So one of the y's goes away, one of the x's goes away. This is 1 and this is 3, and this is 1 and this would be 2. So 4 goes in there 2 times, 7 goes in there 3 times. So that's what's left over. On the top, all we have left is a 2. So it's 2 on the top, and then it's 3x squared y squared on the bottom. That's what's left. All right. And what can x and y not be? Now, with division, you have to check all of those can't be 0. Because if this is 0, then that would be 0. If this is 0, then this whole fraction would be 0, and then you'd be dividing into that by 0, and then this can't be 0 either. So basically, x cannot be 0, because that would create a 0, and y cannot be 0. So 0, 0 is the limiting factor on that one. Okay, switch, or keep, switch, flip. And it makes sense because if you do the inverse operation here, you have to do the inverse here. So if you flip this to multiplication, you have to flip this fraction. So that's compensating for the fact that you're changing the different operation here. So 3x cubed over 5y squared times 5y cubed over 6x to the 5th. All right, so now the 5's can be hacked away. There's 3 versus 5, so that goes away, and there's 2 down here. There's 2 that goes away, 1 lives inside of there, so that's left. So, oh, and then 1 versus 2 of these. Okay, so 3 over 6 is like 1/2. So this is gone, that's gone, that's gone. So I have a y left on the top, and on the bottom that's all gone, and I have 2x squared. And again, there, and there, x and y cannot be 0. All right. Hold on. Okay, somebody came in the room, so I paused it again. So I kept this the same, but factored it. I switched this upside down, and I factored out there. So now I can see that these are the same. So you can hack this away. And then this would be 1 and this would be 3. So what's left is 5 and x plus 1, x plus y. And then here I would have 3. 3 is the only thing left. Now, restrictions are between these two here. The 18 isn't going to come involved. Basically, if x equals y, so if x equals y, then these would be the same, and the same thing minus the same thing is 0, and the same thing over here. So x cannot equal y. That's my restriction. X cannot equal y. That's the restriction on the problem. Okay, keep, switch, flip. So I'm keeping this one the same. So it's y minus 2, y minus 3, and then y cubed, switch 4y squared over, and factor this, x plus 5x minus 2. Yes. Alright. So if y was 0 on either one of those, that'd be a problem. And if y is y, so used to writing x, y is 2 or negative 5. So y cannot be, I wrote x again, I need to stop it. Y is equal to, cannot be 0, that's a restriction, and then negative 5, and then 2. Those are the 3 restrictions. So that would cause division by 0, and then of course 0 would cause division by 0. And for division, you have to worry about here, here, and here. Alright, back again. Another person came in the room. This and this go away. There's 2 of these versus 3 down here, so these all go away, and there's 1 y left. So no numbers cancel out, so I got 5 times y minus 3 over y times y plus 5. Awesome, and then the restrictions are up here. Okay.